Welcome to the lecture on solving linear inequalities. Let's begin by writing out what these symbols are going to look like. So when you see the words less than, that's going to be the symbol that looks like this. Less than or equal to is the same symbol with an equal bar underneath. Greater than flips around to look like that, and greater than or equal to has an equal bar underneath. Sometimes we see the phrase not equal to, and that's just an equal symbol with a slash through it. Now when we solve linear inequalities, there's two ways to show solutions. One way is to show it graphically using a number line with shading to the right or to the left, and the other alternative is to use what's called interval notation. This is shorthand notation that we sometimes use to express our solutions. It requires using either parentheses or brackets. We use parentheses whenever we see open circles or a strictly less than or strictly greater than symbol. We use brackets whenever we want closed circles or we see those equal bars. And occasionally we'll have to refer to an infinity or minus infinity, and whenever we use infinities, we're going to use parentheses around them. So let me show you what I mean. The first example here is a fairly basic one. We want to show x less than 1. So graphically, that would just be using a number line, putting 1 on that number line, and this means I want x strictly less than 1. So we're going to put an open circle around the 1 because we don't want to include it, and we want everything less than that, so we would shade to the left. So that's your graphical solution. Now in terms of interval notation, when you write interval notation, you want to express all these numbers, and we want to do this from the left to the right, just as if you were reading a book. We want to write the number on the left that you start at up to the number on the right that you end at. Now over here on the left-hand side, there isn't really a number that we start out. So mathematically, the way we show the fact that this is going to the left is we use the symbol minus infinity to represent the fact that this keeps going to the left. And then we want to continue this up until we hit 1. 1 is where we should stop. So we're going to go from minus infinity, comma, up to 1. Now since I'm using an infinity, the convention is to always use parentheses around that. And around the 1, I'm also going to use a parentheses because I see that open circle or that strictly less than symbol. So here's my interval notation, minus infinity up to 1. Now if I switch this around and do x greater than or equal to 1, then I would put 1 on my number line, but this time it's going to be a closed circle because I see that equal bar underneath. And I want x is greater than or equal to that, so we're going to shade to the right. So that would be the graphical solution to this inequality. The interval notation here, we start at 1 on the left, and then we go up to go on and on and on here to the right. So we're going to go on until we hit infinity. So we're going to start at 1 and go to infinity, parentheses around the infinity, and a bracket around the 1 because remember this time we wanted to include the 1, and I saw that closed circle or that equal bar. So here's our interval notation. In the next example, this is what we call a triple inequality. It has two inequalities, but it's got 3 parts to it. And what it means is we want all the x's greater than or equal to -3, and at the same time, we want all these x's to be less than 5. So graphically, that would say you want all the x's that are bigger than -3, but less than 5, so that's going to be all the x's in between these two endpoints. Since there's an equal bar next to that -3, that endpoint's going to be closed, and there's no equal bar on the 5, so that endpoint's going to be open. So this would have interval notation starting at -3, going up to 5, a bracket around the -3 because of the closed circle, and a parentheses around the 5 because of the open circle. In the last example here, we have x less than 1 or x greater than or equal to 5. So graphically, we want all the x's less than 1. So here's 1, open circle, less than would be shading to the left. Or x could be anything greater than or equal to 5. So x could be anything here, or it could be anything bigger than 5. So shading to the right of 5, and this has an equal bar, so I could also let x equal 5, so I'm going to use a closed circle. So x can be anything here or anything here. So that's what your graphical solution looks like. How do you write this with an interval? Unfortunately, you can't do it with just one. You're going to need two intervals, one for the left piece and one for the right piece. So the interval on the left starts at minus infinity and goes up to 1. And I want parentheses around both of those because of that open circle and that infinity. The interval on the right starts at 5 and goes up to positive infinity. This time we want a bracket around the 5 and a parentheses around the infinity. Now to show that I want both of these in my solution, this OR, what we use is the symbol, the union symbol in mathematics, which is just this upwards U shape. So this shows that we want the union of these two intervals, or both of these, included in our solution. So here's our final interval notation. Now what we're going to do to extend these problems is we're going to be given linear inequalities, inequalities that have x's raised to the first power. To solve these inequalities, you would solve them just like an equation. There's only one extra new rule that's different than when you solve an equation, and that's the rule that says whenever you multiply or divide by a negative number with an inequality, you have to flip the inequality around. So you just want to look out for that. That's the one thing that might possibly happen. So if we look at this example here, if this was an equation, we would want to get x's on one side and numbers on the other side. Well, we're going to do that same thing for this inequality. So I would start by trying to get my x's together, and I could do that by subtracting 4x from both sides. That's going to give me x minus 2 is less than negative 5. Now I want to get my numbers together on the other side, so I could add 2 to both sides, and that would give me x is less than negative 3. On a number line, this would have the solution of an open circle around negative 3, and we want less than that, so we would shade to the left. Using interval notation, this starts at negative infinity on the left and goes up to negative 3, and I would be using parentheses around both of those. The next example looks deceptively simple. The problem is this isn't just k less than 0, it's negative k less than 0. So this isn't quite solved for k. We need to get rid of that negative. And that negative is essentially just a coefficient of negative 1. So to get rid of it, we just want to divide through by that coefficient. So I could divide both sides by negative 1. That cancels out the negative on the left side, and 0 divided by a negative 1 stays 0. But here is the first example that we have where we are dividing by a negative. So if you multiply or divide by a negative, you must flip the inequality around. So this less than flips to a greater than. So now our solution is actually all the k's greater than 0. So open circle around 0, and greater than would be to the right. As an interval, this starts at 0 and goes to infinity, parentheses around both. In our next couple of examples, what's different is now we have some parentheses. So the first thing we're going to need to do is get rid of the parentheses by just doing some distributing. So here I'm going to distribute this negative across, and then I'm going to distribute this 3 across. So I would have 2y minus 4y plus 3 is greater than 6y plus 3y plus 12. Now you have a couple of like terms on both sides, so clean that up first before you start moving terms around. 2y minus 4y is negative 2y plus 3. 6y plus 3y is 9y plus 12. Now I want to get my y terms together. You can move these terms in either order. You could add 2y or you could subtract 9y. It's up to you. I'm going to add 2y to try and get a positive coefficient in front of that y, and that's going to give me 3 greater than positive 11y plus 12. Now I would want to get my numbers together, so I would subtract 12 from both sides. 3 minus 12 is negative 9, greater than 11y. In my last step, I want to get rid of that coefficient of 11, so I'm going to divide both sides by 11. Notice here that I'm dividing by a positive, so you do not need to flip the inequality around. Now, when I look at this solution, it's tempting to do this incorrectly because we see that negative 9/11ths, so we graph it, put an open circle around it, and then we see that greater than symbol, so we immediately think that we should be shading to the right. Unfortunately, that's not correct because this inequality is kind of written backwards from how we like to do it in mathematics. What we really like in mathematics is to have the variable on the left side and the number on the right side. So if you take the time to flip it around and put the y on the left and the number on the right, you have to flip the inequality around as well. So this greater than symbol actually flips to a less than. So this graph is incorrect, and instead what I need is a number line with an open circle around negative 9/11ths, but this time I want less than that, so I should be shading to the left. So be careful on that. You're probably going to see problems where when you solve on the variables on the right side, take the time to flip it around and therefore flip the inequality around. Otherwise, you're going to be shading in the wrong direction. To finish this off, we have interval notation of minus infinity up to negative 9/11ths, and we've got parentheses around both of those. On the next example here, same idea. We want to get rid of these parentheses first, so I would distribute my negative across. That's going to give me 4 minus 2 plus x is less than x plus 1. A couple of like terms on the left-hand side. 4 minus 2 is 2. And so now at the next point here, I would try to get my x's together. And if you do that here, what you'll notice is something strange happens. The x's cancel out on both sides. What's really important is you always need to look at what is left after those x's cancel out. On the left side we have a 2, on the right side we have a 1. Either what you're left with is true or false, and whichever case it is determines what kind of an answer you're going to write down. 2 is not less than 1 in this case, so this is a false statement. What that means is no matter what x we pick, this is always going to be false. There's no way we could make it a true statement. So no value of x makes this work. So our solution is no solution. You can either write that with a 0 with a slash through it, or you can use words. Either way. Now, just as an aside, if this problem had ended up being 2 greater than 1 instead, which is a true statement, what would that mean about the problem? It means that no matter what you pick for x, it's always going to be true, so every value of x works. If you use words, that means all real numbers are your solutions. How would we write that using interval notation? How do we show that we want all real numbers? Well, that would be the interval minus infinity up to positive infinity. So occasionally you'll see problems like that as well. So if you ever get a problem where your variable disappears, cancels out, if it's false, then you have no solution. If it's true, you get all real numbers for your solution. The next two examples are called triple inequalities. They have 3 parts to them. And what we're going to do is try to solve this left-hand inequality simultaneously as the right-hand inequality. And the way that we do that is by trying to get, sort of as our goal, the variable by itself in the middle. In this case, the variable is r. So I want to try and get just an r in the middle. That would require getting rid of this 3 and getting rid of this minus 1. Which one do I need to get rid of first? Usually we get rid of the one that's farthest away from your variable. So I'm going to get rid of this minus 1 first. How do you undo subtracting 1? You add 1. So what we do to show this simultaneous work here is we add 1 in the middle, we add 1 on the left, and we add 1 on the right. So we're actually going to do it 3 times. Now when we do that, negative 8 plus 1 is negative 7. In the middle, the 1's cancel out, and we get 3r. And on the right, negative 1 plus 1 is 0. So now we just have a 3r in the middle. How do we get this to be just an r in the middle? We have to get rid of that 3, and that 3 is being multiplied by r. So to undo that, we're going to divide by 3 in the middle, on the left, and on the right. Now you can't really simplify or reduce negative 7/3, so just leave it, negative 7/3. In the middle, the 3's cancel, giving us just that r that we were trying to get by itself. And on the right, 0 divided by 3 stays 0. Notice here that we divided by a positive, so I didn't need to flip any inequalities. So what does this mean as a solution? Graphically, what it means is you want all the r's that are greater than or equal to negative 7/3, but at the same time less than or equal to 0. So that's going to be all the values in between these two endpoints. And since they both have these equal bars, we're going to have closed circles around both of them. So it looks just like this. As an interval, that's negative 7/3 up to 0 with brackets around both of them. And there's our solution. Now in the next example here, we have the same kind of problem, but it's a little bit more complicated because I have this fraction. So I want to show you how you can deal with that. You have two options. You can first try to get just a y in the middle here. That would be kind of our goal, is to get just y in the center. And you could do that by first getting rid of the 6 by subtracting, and then trying to get rid of this negative 3/4. The other option, if you don't like fractions at all, is to try and clear out that fraction right away. And I'm going to show you that method. So if I look at my problem here, the only denominator that I see is 4, and that's what I want to get rid of. So I'm going to multiply every single term by 4 to keep this balanced. So I'm going to multiply the left by 4, the middle by 4, and that actually means I'm going to be multiplying both of these terms by 4. And I'm also going to multiply the right side by 4. So I'm multiplying every single term here that I see by 4. 4 times 2 is 8. 4 times 6 is 24. 4 times 3/4, multiplying by 4, has the exact purpose of canceling out that 4. So all you should be left with is that numerator, minus 3, and that y. And on the right side, 12 times 4 is 48. Notice that I multiplied by a positive 4, so I didn't have to flip any inequalities. Now at least I have eliminated my fractions, but I still have some things to get rid of here in the middle. So the next thing I'd want to get rid of is this 24, and it's positive, so I'm going to want to subtract it in the middle, on the left, and on the right. 8 minus 24 is negative 16. These cancel out, giving me minus 3y, and 48 minus 24 is positive 24. Finally, to get y by itself, I'm going to get rid of that coefficient by dividing. So I want to divide in the middle by negative 3, on the left by negative 3, and on the right by negative 3. Now you can't really reduce 16/3, but you can reduce the signs. A negative divided by a negative becomes positive 16/3. In the middle, you just get that y, and 24 divided by negative 3 is negative 8. Now I need to erase this symbol here because what did we divide by? We divided by a negative number, so we have to be super careful here. That means we need to flip the inequalities around. So both of these less than symbols become greater than symbols because we were dividing by negatives. So this is what we end up with. It should look a little bit backwards. Remember, in mathematics, we want to think left to right. The smaller number should be on the left, the larger number should be on the right, and in this case, the smaller number is this negative 8, and the larger number is the 16/3. So they're kind of in the wrong order. So you want to take a moment to actually flip it around to put it in the right order. You can leave the y in the middle. You're just flip-flopping these two numbers on the outsides. And if you flip-flop the numbers, you have to flip-flop the inequalities back into their original order. So the correct way to write this is -8 less than y less than 16/3. Graphically, that means you want all the y's that are bigger than -8 but less than 16/3. So that's all the numbers in between these two endpoints. And these didn't have any equal bars, so both of these endpoints are open circles. As an interval, this is -8 up to 16/3 with parentheses around both. Okay, to finish off, we're going to do a couple of word problems here. The first one is a translation problem that we're going to solve. So the question says, when 2 is added to the difference between 6 times a number and 5, the result is greater than 13 added to 5 times the number. Find all such numbers. So this is kind of a messy one. We want to translate it first. When I see this phrase, is greater than, that's how I know that this is an inequality, because is greater than is that symbol right there. Now what do we have on the left side and what do we have on the right side? Well, on the left side, it's this first phrase that I have. I want 2 is added to a difference. So I want 2 added to some stuff. And what do I want for that stuff? It's the difference, which means subtraction, between 6 times a number, which would be 6x, and 5. So we want the difference between 6 times a number and 5, that's the 6x minus 5, and we wanted 2 added to that. On the right-hand side, we want 13 added to 5 times the number. So 13 added to 5 times our number x. So this is how this whole sentence translates into an inequality. Once you have it translated, you just have to solve it. So on the left-hand side, we have a couple of like terms. We're going to get 6x, and 2 minus 5 is -3. Now we can get our x's together. I'm going to subtract 5x over to the left-hand side. 6x minus 5x is x. We get x minus 3 greater than 13. And then to finish solving for x, we could add 3, and we get x is greater than 16. Not once did I multiply or divide by a negative, so there was no flipping of the inequality needed. So what's our solution? All the numbers greater than 16. If I use intervals, that's going to be start at 16 and go bigger. So start at 16 and go to infinity. There's no equal bar, so these are going to be parentheses around both. Finally, our last example here, a common question that students ask once they get to their test scores and their test averages. So suppose that you received grades of 94 and 82 on your first 2 math tests, and you want to know what possible scores on the third test will give you an average of at least 90. So let's say we're trying to figure out what this third test score should be. It's unknown to us, so I'm going to call it x. If I want to get a test average of at least 90, we need to figure out how to average our test scores. And as you probably know, when you average things in mathematics, that means to add them all up and divide by however many you have. Well, we have 3 tests, so we're going to add up our 3 test scores, divide that by 3, and we want that average to be at least 90. So here's what this inequality would turn into. I'm going to add up my first 2 test scores with this mysterious third one, x. There's 3 tests. I'm going to add them up and divide by 3 to get the average. and we want that average to be at least 90. So what inequality do you think it should be if I want at least 90? Well, that means it could be either greater than 90 or it could even equal 90. So at least means greater than or equal to. So this is the inequality that I need to solve. Now to solve it, the first thing that I like to do here is, again, get rid of that denominator. Get rid of those fractions if you can. And the real simple way to do that is just to multiply both sides by that denominator. That has the purpose of just canceling out that denominator. Do not distribute that 3 across the top. This 3 just cancels out the denominator. The numerator should stay unchanged. But on the right-hand side, 90 times 3 now gives me 270. So we have a couple of like terms over here on the left side. 94 plus 82 is 176. And to solve this for x, all we have to do is subtract that 176 to the other side. And 270 minus 176 is 94. So what grade do I need on my test in order to get at least a 90? I need to score at least a 94 on my third test in order to reach that average of 90 or higher. Alright, that concludes our lecture on solving linear inequalities. Good luck.